All right, so let's go back here to our EC2 section. So from here, I can type in my EC2 from here, just in case, just in case you didn't have, all right, you didn't have it on your own recently visited, okay? So you can type it out here, and then it will give you this, okay? So you click on EC2, and so that's where we're going to be launching different instances, and we are going to stay within the Amazon free tier, all right, so that we don't get charged or we don't get billed unnecessarily, okay? So you can see on this dashboard, it shows you the instances that are running. So presently, I don't have any instance in my account that is running at the moment. So it is 0. There are 5 instances in my account, okay, which means instances in this case, it just refers to as a system, all right, as a system, okay? That is what instances refer to, because every one of us, whether you're connecting with a system or with mobile phone, a tablet, whatever it is that you're connecting with, all right, it's still a computer that you're using, okay? So instances within the cloud environment, all right, is something that just basically means a system, all right? But then when you talk about a system, every system has, all right, a purpose. So which means what you can use your mobile phone to do, all right, you know, on the go. Well, that may be suitable, okay? You might have some applications that if you have them on your mobile phone, on the go, you can do a few things, you know, like your WhatsApp, all right, your Telegram, you know, your email and all of that. If you have it on your mobile phone, it's easy to check your mails, reply to an email, send an email, all right, get WhatsApp messages, send responses to people and all of that. It is easy when you have your mobile phone with you. But then there are certain things that you want to do that you require, all right, a system, a computer system. It might be a laptop, it might be a desktop. For example, if you want to say, you know, you have maybe, let's say you have an application that you want to submit, and then as part of the application, you are required to type or to write, maybe let's say, you know, a 500 character statement or something like that, and then you are required to also fill out a Google form and type in something. Now, in that case, you might need a computer system, because typing out that letter, you want to be sure that, you know, in terms of correctness, your grammars are correct, all right? In terms of clarity, what the message you're trying to pass across is clear, people can understand what you're trying to communicate and those kind of stuff, right? So in that instance, if mobile phone may not be suitable for that particular purpose, all right, a mobile phone may not be suitable for that particular purpose. Well, somebody can say, well, if I have a tab, I can use my tab. Well, that's okay. But let's consider that, you know, what you want to type is about maybe a 10-page or a document that you have to type, and then you have to do some referencing and all those kind of stuff. All right, then in that case, you just have to use a computer system. So every computer that we have, they all have their purposes, right? Now, let's take it a step further. Let's say, for example, you also need a system, or you want to do something, and then there are certain applications you want to run on your system. Now, those applications, sometimes you might have a mobile version of that application, but of course, you may not get that result that you intend or that you want, okay? And then if you want to use a normal computer system also, you may not get a result that you want. So you can go for high-end, you know, right, systems. And that's why in organizations, you will discover that every staff member has access to a system. All right, everybody has access. So it can be a desktop, it can be a laptop, but everybody has access, all right, to a system. And you will also discover that within the organization, there are systems that are a bit bigger than every other system. And then they refer to them as, oh, that's our server, you know, that's, you don't touch it, oh, it's the IT people that can manage it and all of those kind of things. So they say, so just leave it here. So if there's anything, call the IT people to come and touch it. You know, they are the one that understand it. Now, those kind of systems are, all right, they are server systems. So now what's the difference between a server system and a normal desktop computer? Basically, architecture, all right, because every system, like I mentioned earlier, is built for a particular purpose. All right. So the kind of architecture that you're going to have built into a server is going to be different from the architecture, all right, that you have on a mobile phone. Okay. Now, it does not matter how sophisticated your mobile phone is, even if you're using iPhone 16X, let's just assume there's 16X now, right? I know we have 14 at the moment, but let's say you have 16X. There are still certain things that 16X cannot run. Okay, there are certain things that the 16X cannot run. For example, if you are into data science, for example, you want to manipulate some data, you need some machine learning algorithm to manipulate data for you and all those kind of stuff. You can't do that on your mobile phone, no matter how powerful that mobile phone is. You need a server system to do that for you, because that server system has an architecture, all right, that can support that thing that you want to do. Okay, so every system has a purpose. That's what we're saying. Now, in the cloud environment, you have all the system, and then in AWS, it is called an instance. Now, when you get into Azure, you can call it something like a virtual machine. Okay, in GCP, in Google Cloud, they call it VMs. All right, VM is just short for virtual machines, right? But each of the systems that you have within this cloud environment, they have been built for a particular purpose. All right. Now, what could mean, if you look at what we have here, we have instance, all right. These ones are the instance available, instance running. We have dedicated host, all right. If you look at this place, there's the instance type, all right. This left side here, there's the instance type, there's the reserved instance, and there's the dedicated host. All right. Now, all of this instance type talks about the architecture. Okay. So going back to what I said earlier, that every system is built for a purpose. Okay. So the instance type, all right, or basically what you want to do, okay, the kind of software, the kind of application you want to run is actually the thing that determines the kind of system you are going to procure. So which means in a production environment, nobody just goes to the market and just buy any system. Okay. So which means you have to gather what you call application requirements. You have to understand what applications do we want to run on this system. Okay. So if you gather all of those requirements, that is what is going to inform the kind of system that you're going to procure. Now, when we talk about the kind of system, we're not just saying, okay, the kind of system, do you mean maybe HP or Lenovo or Dell, or what do you mean by what kind of system? What we are actually saying is we're not talking about the manufacturer, we are talking about the architecture. All right, so we're talking about things like the CPU size, we're talking about things like the RAM size, we're talking about things like the hard drive, which is the storage size. And then we're also talking about, if you're talking about processor as well, you're going to be talking about the different processing architecture. All right, I'm sure some of us, we know there's Intel Pentium. Initially, there was Intel, Pentium 4, Pentium 3. But nowadays, we talk about Core i3, Core i5, Core i7. Lately, somebody was telling me now that there's Core M7 and all those kind of things. So the application you want to run is what will determine the architecture that you're going to go for. All right. So in the cloud environment too, you have what you call instance types. All right. In your cloud environment. Now, the way it works in the cloud environment is this. AWS has separated everything into different categories, right? Now, there's what you call the compute optimized system. There's what you call the memory optimized system. There's what you call the storage optimized systems. Now, each of the systems, they have their own purpose, all right? And there's what you call the general purpose system. Now, before we start deploying our EC2 instance, let's look at, all right, AWS, okay, instance type. Let's get some understanding about this whole thing, okay? AWS instance type. Now, let's see what we have, okay? Because this will give us the understanding that we need regarding systems. Now, great one. Now, if you look at on my left side here, you have, all right, different instance type. right? So there's the general purpose, there's the compute optimized, there's the memory optimized, there's accelerated computing, there's storage optimized, there's high performance computing, and all of that. Now, what you want to do within your organization is actually going to determine, all right, what you want to run. Now, what do I mean? Now, for example, if you go to my instances tab here, now you will see here that I have quite a number of servers that I have deployed, all right? Not all of them are running at the moment. If you look at it, I have a Jenkins server. If you look at the instance type of that Jenkins server, it's T3 medium, okay? We're going to understand this. It's T3 medium. So why do I use a T3 medium? Why not a T2 micro? Because a T2 micro is covered under the free tier, which means if I use the T2 micro, I'm not going to get charged. Nobody's going to bill me for anything, at least as long as my account is still under the 12-month free tier. So why do I have to go for a T3 medium? And then for my Nexus server as well, I actually went for a T3 medium. So the question is, why go for that kind of server? Now, again, it boils down to what is it that I want to install on this system. Now, for example, in an office environment, most of the system that you see, maybe for example, if you go to a bank, quite a number of the system that you see in the banking hall that all this cashier and all those people use, some of them might not even be more than, let's say, Core i3. All right, because they don't use them for any high processing job, right? The only thing they use it for is just to go to the bank website application, get people that want to pay, people that want to deposit. So there's really nothing serious that is running on the system. All right, so they can afford to go for a system that has maybe just 4 GB of RAM and then maybe a Core i3 processor, maybe 500 GB of storage, because even the stuff that is using the system does not store anything on that system, because they interact with an application, which is basically on the web browser. So everything that they do is saved on a server somewhere. All right, so those ones can go for a system that is not too large, right? So whatever it is you want to deploy is what will determine the size, all right, the instance type that you are going to launch. Now, my one is T3 medium here, because if I use the T2 micro, my Jenkins server may not function properly. All right, and the T2 micro only gives me access to 1 gig of RAM and 1 gig of CPU. All right, so if I'm running a Jenkins pipeline using that kind of server, I'm not going to enjoy it. It's going to give me a lot of headache. Okay, because if I have processes that has to run, let's say you have like 100 processes to run, and you're using a system that just has 1 gig RAM and 1 virtual CPU, then you're not going to get the result that you want. It's going to give you a lot of headache, right? But with the T3 medium, I have access to, for example, if I go to the instance type, all right, if you go to, so this is the T2 micro. So it tells you have 1 virtual CPU, you have 1 GB of RAM, all right? But if I go with the T3 medium that I went for, look at that, it gives me 2 virtual CPUs and 4 GB of RAM. So that's still kind of reasonable, all right? That's kind of reasonable, because it's still 2 virtual CPUs and 4 megabyte of RAM is still something that I can still work with, all right? And it will still deliver what I want, all right, for me. So let's quickly look at this before we launch an instance. So you have the general purpose, and it tells you that the general purpose provides a balance of compute, memory, and networking resources, and it can be used for a variety of diverse workloads, right? Now, so which means if you're testing out something, so you see that all the T2 medium, the T3, and the T4, everything are under the general purpose, okay? So if you look at it, you have all your T3 medium, all right, everything is under the general purpose, right? So your T2 micro is also under the general purpose, because they consider them as systems that if you want to just try out anything, okay, you are not sure, all right, of your application requirement yet. Let's put it that way. You are not sure of your application requirement just yet. Now you can use the general purpose instance type to just test it out. Now, once you're sure about your application requirement, then you can begin to move to things like compute optimized and memory optimized. So the general purpose gives you like a level playing field to just choose any instance of your choice to test out things, all right, that you're not sure, right? You're not exact about, all right, the compute requirement. Okay, so the general purpose fits into that category, all right? So that's what that does for you. Okay, so there are different, all right, instance types that you can choose from, but the most popular ones are the T2 and the T3, okay, because it's general purpose. So you can use that to test out anything. Now, let's say, for example, there's another one called compute optimized. Now, compute optimized instances are ideal for compute-bound applications that benefit from high-performance processors. All right, they benefit from high-performance processors. Okay, now what does this mean? Now it says instance belonging, all right, to this category are well suited for batch processing workload, media transcoding, high-performance web servers, high-performance computing, scientific modeling, and gaming. So which means quite a number of these online games, Call to Duty, all those online games that you play generally, all right, compute optimized instances are the best instance that are, suitable for such processes. So those who are also doing scientific modeling, right, those who are into maybe genetics modeling, excuse me, those who are into maybe machine learning, data science, all those kind of things, you don't want to run your workloads, right, on a general purpose computer. You want to run it on a compute optimized, all right, computer. Excuse me. All right, so you want to run it on a compute optimized. Now, what do you need a compute optimized system? Now, basically what we are saying with compute optimized is any application that consumes a lot of processor, or any application that requires a lot of compute power, all right, then you want to go with compute optimized system. So we have things like C7GN, blah, blah, blah. So if you look at it, to give you all right, so if you look at this one, it tells you like you can have up to like up to 250 gig of this, 25 gigabit of bandwidth. If I click on this one, to tell me, all right, the instance size, so you can have one virtual CPU. If you scroll down, you can see that you can have as much as 64 virtual CPUs and 128 gig of RAM. That's a lot, and it's going to be really very expensive, right? So that's compute optimized. So basically what we're saying is that any application, any workload that requires an enormous amount of processing power, then compute optimized is going to be your best bet, all right, for that. So if you look at this one also, all right, this is another computer optimized instance. If you look at this, it started from 2 virtual CPU and then 4 gig of RAM. So if you scroll down, you'll see that it just started increasing. So you can see you can have as much as 128 virtual CPUs. That's a lot, right? And then you can also have like 256 gig of RAM, all right? That's quite on the high side, okay? But we have organizations that are using those kind of, systems because they run crazy workloads, right? That needs a lot of processing power, okay? So that's when you want to go for compute optimized. And then you have the memory optimized. Now, memory optimized instances are designed to deliver fast performance workload for large data sets in memory. All right. So if you're doing things like in-memory caching, in-memory storage, all right, maybe you have applications that use the memory a lot. And then in-memory means that, there are some applications that you have that they save some of their data inside of the memory. Okay, I don't know if some of us have heard about things like Redis engine, which is an in-memory or a database application. There's the memcached, all this kind of stuff. All right, they use a lot of memory, all right, to store, all right, intermediate, all right, data or data that, let's just say volatile data kind of, okay? So those kind of instances are also there. So if you look at it also, this one, there's going to be a lot of memory. So you can see 1 virtual CPU and 8 gig of RAM. And if you scroll down, you can see that you can have as much as 512 gig of RAM. That's almost a terabyte of RAM, right? So just half of a terabyte. So you can see that. Okay, so basically this talks about application that uses, all right, in-memory storage. An example is Redis cache. Okay, and the purpose of the Redis cache is this. This is just basically what it does. Now, if you have an application, all right, hosted on a particular server, and you have your client, all right, make a request to the server. Now, you want to make sure that things are a bit faster, all right, for your client. such that anytime they need to access your website, you don't have to go, all right, to the server every time, right? You need an intermediate system that once they make a request to the server, that intermediate system stores, all right, that request that they have made, so that by the time they are coming back, they don't have to, their request doesn't have to go to the server. It just stops at the intermediate system and then it gets delivered, all right, to your client. Now, that intermediate system is going to need a lot of memory to store. In other words, what they call it in the real world sense is caching. Okay, so there's a server, there are resources on the server, and then you have different clients from different places, all right, that request, resources from that particular server, all right? Now, every time they want to make a request, the request goes directly to the server. Now, if everything is going on like that, your server may soon wear out, all right? There may be a lot of traffic that the server may not be able to handle in real time, all right? Now, in order not to put too much load or too much pressure on the server, you now put a system in between the client and the server. All right. So anytime your client makes a request, now if they make the first request, that request, all right, kind of the reason it is bypassing intermediate system is because the intermediate system does not have, all right, what the client is requesting as of that moment. Okay. So your intermediate system will look at its own database and see, oh, okay, this request that this client is making is not something that I know about. So your intermediate system is going to allow that request to pass and then go to the server directly. Now, by the time the server is responding back to your client, okay, now the request is cached into the intermediate system. All right. And then the client gets the result of what it has requested. Okay. Now, let's assume that somebody or another client is also trying to make the same request to the server. Now, the request is not going to go to the server directly. It's going to stop at the system that is standing in between, because somebody has made a request earlier and the response has been cached, all right, inside, all right, the intermediate system now. Now, if anybody is making that same request, it doesn't have to go to the server. It stops at the intermediate system. Now, that intermediate system will need to have a lot of memory to store all of those content. And that's why it's called caching. All right. That's the name for it. It's called caching. All right. C-H-C-H-I-N-G. All right. So it's called caching. So anytime anybody is making any request, it stops at the intermediate system. The intermediate system delivers the result, all right, to them. And at intervals also, it can be configured in such a way that that thing that the intermediate system has cached, the intermediate system can also, there can be a mechanism for the intermediate system to check with the server if that particular thing has changed, all right, so that your intermediate system can deliver current data, all right, to your client every time and not deliver stale data to them. Because when you catch something, all right, and then that information has been changed on the server, whatever it is that you have been cached and you are serving to the client is no longer consistent with what you have on the server, right? So there's a mechanism also such that the caching system can also check with the server at intervals to update its own, all right, cache, such that anytime that the client system makes a request, all right, the intermediate server is able to serve them, all right, updated and current content. Okay, so that is where you need a memory optimized, all right, system. Now, all these things that we are talking about are interview questions. Okay, so you need to be able to understand it. For some of us who maybe you have an interview or maybe you want to apply for jobs and all that, these are interview questions, because by the time you get to an interview and they are asking you, okay, can you tell us the different instance type that that AWS has? Okay, now you can't just tell them, oh, we have general purpose, we have compute optimized, we have memory optimized. You must be able to tell them why and when do you need a compute optimized, why and when do you need a memory optimized, and when, all right, and why you need a general purpose system. You must be able to provide that explanation, all right, to them. Okay, and that's why I'm providing this explanation in details. Okay, so that's why you need a memory optimized system, and then you have what you call the accelerated computing. Accelerating computing instances are hardware accelerators or coprocessors to perform functions such as the floating point numbers calculation, graphics processing, or data pattern matching. All right, and then more efficiently than is possible in software running on CPUs. Now, there are certain softwares that utilizes the CPU a lot. Now, an example of that is what you call the Jupyter Notebook. For some of us who have heard of it before, or for some of us who have heard of data science, all right, before, or machine learning and all that. Now, when you are running a machine learning program, all right, using the Jupyter Notebook, it consumes a lot of CPU. Now, how do I know? A friend of mine was conducting research, I think in 2020 or something, and we had a server within our organization, and that server has about 64 gig of RAM, and it has about, I think, 16 cores of CPU. Now, by the time he's running his machine learning program, he was trying to do a research on, a machine learning system that can help to detect breast cancer and all of that. So what they do is they get a lot of data, right? A lot of images, they call it images. So they get a lot of images, and then they have this algorithm that will work on those images to recognize patterns. So what they do is that when they get those images, now they get the correct images, all right, and then they get the images that are not so correct, and then they feed all of those data into the system to train the algorithm, all right, in order for the algorithm to be able to recognize, all right, a breast cancer image, all right, from an image that does not have, such, all right, breast cancer. So they call it, one is malignant, and then they say one is benign, right? So the one that is malignant, the one that is benign. So they try to do all of that. Now, by the time they put in all of those images and then they are running this machine learning on this data and all of that, it gets to a point where it almost uses all the RAM and the CPU that you have on your system. Okay, so if you're doing things that require a lot of graphics processing, right? Maybe you're developing a game application, or maybe you're doing things like, data science, like I just mentioned, that requires a whole lot of CPU. Now, if you look at it here, it says possible in software that is running on CPU. Now, we talked about the in-memory cache the other time about Redis. That one runs on memory, but then there are applications that consume your CPUs, right? Those are applications like, and machine learning and all those things. Okay, so you want to use accelerated computing for those ones. Now look at it. Now this is kind of crazy because 96 virtual CPUs, look at the size of RAM. The RAM is about 1 terabyte of RAM. That's crazy, right? And then you have GPU also, 8 gig of GPUs. Now all of those instances, all these kind of instances are instances you won't see in a small, medium organization. These instances are things that are used in enterprise, right? Places like Microsoft and some of these enterprise organizations, right? Because if you want to look at the cost for this server alone, an hour of usage of this can be around maybe $300, $400, $500 just for 1 hour. Okay, so it's really pretty expensive. All right, so that's accelerated computing. Now you have the storage optimized. Now, storage optimized instances are designed for workload and require high sequential write access to very large data sets on local storage. They are optimized to deliver tens of thousands of low latency, right, blah, 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 and all of that. Now, where do you need a storage, all right, storage optimized system? Now, if all of us, we have accounts with, all right, banks, and, you have the mobile app, all right, on your mobile phone. Okay, so if you want to do transfer, you can just go to your app, do your transfers and all that. Now, all those things that you see on the mobile application, your username and your password are used to authenticate, right? Your transfer, the money, and all those things that you see, everything is stored in a system that is called a database, right? A database. Now, a database holds all of those records, the user data records, your account details, the money, your account, and all those things. And then there's a word that they call all those kind of workload. Now, there's the OALP, which is online, all right, application processing. And there's the OLTP, which is the online, all right, transaction processing. Okay. Now, you can imagine the number of people that uses maybe OPay, for example. Let's use OPay, for example. Now, there are thousands of millions of customers that do transfer with OPay on a daily basis, right? Money Points, all right, all those fintech applications. There are thousands of people, millions of people that are using it for transfers, every day. This one is transferring money to this ones. Now, all those values, all right, all those money, you want to transfer 1 million to somebody, you type in 1 million. Now that value, everything is stored in a database, right? And at the speed of light, you can transfer money now, and then the other person gets the alert, and then it goes, and then that one also takes his phone, transfers money, and then another person sees it and all of that. Now, that requires, right, a sequential. If you look at what we have here, it says sequential read and write access to very large data sets. Okay, now that application itself is deployed on a system, and all those data that you see, your account, your money, and everything is stored on a database. That database is also on a system that has a local storage connected to it. Now, you can imagine the amount of read and write that we do every day. I'm sure today now, if I have asked us, I'm sure most of us we've done maybe one or two transfers today, right? So, and you're not the only person. So look at the amount of people that are making transfers every day. People sending money, people receiving money, people paying for things with their ATM, people doing transfer for all those kind of things. Now that requires high sequential read and write access. All right. Read and what? And write access. So if you're doing anything that involves, all right, real-time transactions, like, all right, like your bank applications and stuff like that, okay, you would go for a storage optimized kind of instance where you have a lot of storage, and then the kind of instance you're going to use is something that will help you, all right, to be able to do that read and write access, like, all right, at the speed of light. Okay, so in that case, you really may not need, all right, a compute optimized. You may not need a memory optimized, but you need something that anytime anybody wants to access their account, they are able to access their account like right now, all right, without any kind of latency and things like that. And that's why it says they are optimized to deliver tens of thousands of low latency random input and output operations per second. Okay, per seconds. So organizations like, Access Bank, Zenith Bank, all these bank, applications, this is what they go for, all right, because people use those applications every day, every single day, 24 hours a day. Everybody uses all of those applications. So they cannot afford a situation where somebody wants to access his account and then it's taking days, it's taking hours to load, he wants to transfer money, can't move it, all right, and all those kind of things. Okay, so they go for storage optimized instance type. And if you look at it here, you can see that here now we now have some kind of massive storage, and all the storage are what? They are using SSD, all right, which is a solid state drive. So you can see this is about 1 terabyte. This is almost 2 terabyte. This is almost 4 terabyte, about 8 terabyte. All right, 8 terabyte times 2, that's about 16 terabyte, and then 8 terabyte times 4, that's almost 32 terabytes. All right. Well, what am I even saying? That's more than 32, because this is 7,500 gig. All right, already. Okay. So that's massive. That's a lot. Right. So if you look at the use cases also, it tells you that this instance, right, you can see what I was saying. I was talking about database. Can you see? It's stated here. I think you'll see that earlier. I just knew. All right. So if you look at it, it says the use case is this instance when the number of transactions per second for intensive business critical workload, which have medium-sized data set that can benefit from blah, 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 such as relational database, right? So I told you earlier, I said all the applications that you use on your banking, everything is stored on a database, right? So for banks, okay, banks majorly, they will go for storage optimized, all right, instance type. Okay, that's what they'll go for. Now we have the last one here, which is the high performance computing. High performance computing are purpose built for price performing running high performance workloads at scale. This is HPC instance ID for doing dimensional processors, such as large and complex simulations and deep learning workloads, all right, deep learning like ChatGPT. Okay, now the ChatGPT that everybody's talking about actually uses, all right, this kind of instance type, HPC, high performance computing. You can imagine if you go to ChatGPT and you tell ChatGPT, can you tell me the largest city in Africa or other things? It gives you the response like now, instant. Okay. So all those kind of applications that, of course, require some kind of deep learning, okay, kind of stuff, they go for the high performance computing, okay? And if you look at those high performance, you can see what we have here, 64 cores, and then 1 terabyte of RAM. Look at the storage. The storage is also massive, right? Okay, so that's for high performance computing, and then you have another option here, and that's also still really okay as well. Okay, so these are the different instance type that we have. All right, I've given us a rundown of general purpose, compute optimized, memory optimized, accelerated computing, storage optimized, and I've told us what each and every of those things, all right, what they do. Okay, because if you go for an interview, they expect them to give them a solid explanation. It's not enough to just know that, you know, it's not enough to know that you have this kind of applications and all of that, but you must also be able to, all right, understand what they do, okay, and how you can explain that. All right, just a minute, please. I will continue shortly. Please just give me 1 minute. All right. All right, so that's thank you. So that's the rundown of the different instance type that we have and what each of them, all right, what they do. Okay, so please, if you have any kind of interview and all that, be able, you know, right, make sure that you are able to give them an explanation of what each of the instance type, right, what they do, just like I've explained to us. Okay, so that way it shows that you really know, all right, what you are saying. So here you can see that we have 396 plus instance type. We can really use every one of them. All right, for our own training, we're going to stay within the T2 micro. All right, we don't want to go outside of the T2 micro because it's still free. You're covered under the free tier, so you don't want to get charged unnecessarily. All right, so let's go to instances and let's see a few things, all right, about this instance. Now, if I click on launch an instance, okay, now on this page, on this particular page, all right, I will have to type in name of that instance, right? Now, one thing I want you to understand is this. This EC2 that we are talking about, the Elastic Compute Cloud, which is more like you're deploying a system, is similar to when you order for a system on Jumia or Konga or even on Amazon, for example. It's the same thing, right? Now, when you want to buy the phone that you are holding, there are certain things you put into consideration. Okay. Now, I'm sure some of us were wondering, okay, should I go for a Techno phone? Should I go for an Infinix phone? No, I think Samsung is better and all of that. Now, and some people may say, I can't use all those Android phones, you know, I'd rather go for Apple. Well, whichever one you go for is still a mobile phone at the end of the day, right? Now, by the time you settle on the brand, okay, so which is, okay, now I want to go for a Samsung phone or I want to go for an Apple phone. By the time you settle on the brand, now you have to consider other things, okay? What are the other things that you will consider? You consider things like the RAM. Okay, this phone that I want to buy, what's even the RAM? Is this 6 gig? Is it 4 gig RAM? You have to consider all of that. Now, after you have done, okay, and say, okay, let me go for 6 gig. 6 gig is fine. Again, you have to consider the processor. Okay, this phone that I want to buy, is it quad-core processor? All right, is it this, is it that? You look at the processor, okay? Now, again, after you consider the processor, you also consider what? You consider the storage. Okay, I don't want to buy a phone that does not have enough storage. Is this 64 gig? Is it 128 gig? Or is it 32 gig? Okay, you consider all of those things. After you have considered all of those things, you now say, okay, now I am going for a Samsung phone. Okay, 128 gig, 6 gig of RAM. I think I'm okay with it. Let me buy that. And then you buy. The same thing applies to a computer system. When you want to buy a computer system, you also look at the brands. Oh, okay, HP is good, Dell is there, there's Lenovo, there's Asus, there's Acer. You look at it and say, okay, let me go for HP. I think HP is better. The brand name has been around for a while, so I think I can trust their product. Now, when you settle down with the brand, you also have to consider other things like I just mentioned, the RAM, the CPU, and all of that. Now, after you have looked at all of that, also you also consider the operating system. Okay, So if you're dealing with an Android phone, right, you know, okay, it's going to be an Android phone. So it can be Android 14, or it can be Android 12, or it can be Android 11. If you're dealing with an iPhone, you have to consider, okay, what iPhone OS version is running on this particular iPhone. So you consider all of those things, right? Now, in the cloud environment also, whether you're dealing with Azure, or you're dealing with Google Cloud, or you're dealing with AWS, you also have to put all of those things into consideration. Okay? You have to what? You have to put those things into consideration. So for example, I want to launch an instance. Now, I must know the instance type that I want to use. And also, I must be able to determine the operating system that I want to run. All right. So if you look at it from here, there's a name, so which means you can give it a name. So I can say, all right, free class VM. And then it takes us to a point where we have to choose an operating system. Okay. So I can look at it and say, well, I think I want a Windows operating system. I want an Ubuntu system. You know, I want a Mac system and all of that. Now, one thing you must know is this: all this operating system that you have here, now there are some of them that are not covered under the free tier. For example, if I click on Mac, the Mac OS, all right, Mac OS, all right, OS Ventura 13.4 is not covered under the free tier. Which means if I want to go with this kind of operating system, I really have to pay. Right? I have to pay. Now, if you scroll down, you will see that the Mac operating system as well does not support the T2 micro. So the least, all right, system that is support, it comes with 12 gig of RAM, all right, 12 virtual CPUs and 32 gig of memory. That's a whole lot. Okay. Now, even if I click on all generations from here and I click here, I will still see that all the T2 micro, even the T3 medium, I can't use it for a Mac operating system. And so this is going to cost me a whole lot. All right. So the same thing that you do when you want to buy a system, when you want to buy a phone, you consider so many things like CPU and is also the same thing that you have to do within the cloud environment. You have to consider all those things. And that's why I said earlier, I said, nobody will just go and buy anything or any system off the shelf just like that. You have to consider the application you want to run. For example, if you are somebody who maybe you take a lot of pictures with your mobile phone and then you have a lot of pictures and a lot of video, maybe for example, maybe you do a lot of TikTok videos, right? You don't want to go and buy a phone that is 4 gig RAM and then 32 gig of storage space. That will not work for your TikTok that you want to do, right? You want to go for a phone that has maybe like 128 gig of storage and maybe around 12 gig of RAM and all that, so they can do your TikTok video without any kind of hindrance. All right. And for example, if you're somebody also who is into designing, right? You don't want to go for, maybe you have Canva on your mobile phone for your designs and all that. You don't also want to go for a phone that is 4 gig RAM and then the storage is just 24 gig of storage. No, that will not work in the long term for what you want to do. So the same thing in the cloud environment, by the time I choose my operating system, right? Let's say, for example, I want to go with an Amazon Linux operating system. If I go with an Amazon Linux operating system, then I can do the free tier eligible just to test things out, right? I can go with my T2 micro. You can see that that gives me 1 virtual CPU, 1 gig of RAM, and all of that. I can do all of that. Okay. So at the end of the day, it boils down to what you want to do. That is what will ultimately determine, all right, the kind of instance type that you're going to launch. Okay. Now, again, if you look at it again, for every system, you must have a security in place, right? You don't want, for some of us, your phone normally has, all right, maybe fingerprint to unlock it, or maybe you have a pattern on your phone to unlock it. And we even do, we go extra step further. And for some of us, each of the application on your phone is also locked. So even if somebody succeeds in understanding the pattern that you use to unlock your phone, if they want to go to your gallery, for example, to look at your picture, they will need a password. If they want to go to other applications on your phone, maybe to Instagram or so, they need a password. Every application is passworded. So in the cloud environment as well, you also need some kind of security, all right, to authenticate with your server. And that's where the key pair comes in. All right, you have to create a key pair in order for you to be able to access your server. So you can click on create key pair, give a key pair a name, You can use any of this format actually, whether we're dealing with Windows or Linux or Mac, you can use any of the format. Okay, any of the format will work. And then once you're done with any of the format, you can click on Create Key Pair. And then once you click on Create Key Pair, it downloads, all right, a private copy on your system. So anytime you want to authenticate with that system, that is what you use. We're going to see that, all right, in the course of this class. Okay, I'm going to show us that. So once you create your key pair, then you can decide on which one that you want, all right, to use. Now let's create a key pair. So I'll click on create a key pair. So let's call this, all right, free class key. Okay. So let's go with pen and let me create it. I'm going to show us the second option also, all right? So just don't worry. I'm going to show us the second option as well. So it's going to ask me to save, all right? So I'm going to choose a location to save it. So I'll click on OK. Okay, let's put this in the download folder. So I'll save it in my downloads. All right, it's been saved. So I have my free class key pair. Now, already we talked about VPC, so I'm not going to really dwell too much on that. So let's choose our free class VPC. Okay, so that's the free class VPC. And then in the last class, we also created a security group. And then I think I explained what a security group is. That is a stateful firewall. You have to specify what is incoming. You don't have to specify what is going out. Okay. And then I remember we created a security group, all right, earlier, which is this one. All right, we used the default security group. So we're going to go with that. And the same thing you do with a normal system, you have to configure storage. Okay. So if you want 100 gig of storage, it's okay. But of course, if you're under the free tier, you can go beyond 30 gig of storage. Okay. So I can increase this to 30. Okay. So if that's what I want, but it's okay. But of course, 8 gig, it's all right. Okay. Now, everything has been configured. Okay. And then I will launch my instance. Now, there are a few ways I can access my instance. All right. There are a few ways I can do that. Let's filter this to show us instance state and then equals running. So I just only want to see instances that are running, right? So now this is the instance, all right, that we just created. Now there are a few ways I can access this particular instance, right? I can click on it, okay, and go to connect. And then I can use the EC2 instance connect. And from here, I can actually, all right, connect with my instance. So I can click on connect from here. And then if everything is all right, my security group is good, I should be able to connect. But now, if you connect using this particular option, you won't necessarily need a key pair. Okay. But somebody may want to have, okay, so the key pair that we downloaded, so how do we use it? How do we use it to connect to, all right, our instance? So if you look at it here, I'm connected to my instance, all right, it's a Linux server. I can begin to do whatever it is that I want to do, all right, with it. Okay. So that's good. Now, let's see how we can use the key pair that we have downloaded to connect with this, all right, particular instance. Now, I'm going to show us two ways that we can do it. The first one is to use the normal command prompt that you have on your system. And then you can also use, all right, SSH applications like Terminus and other, all right, applications to also access your instance. But let's start with the CMD, all right, the command prompt that comes with our Windows. Everybody knows, all right, command prompt. So how do I access it? Now, I'm still going to come on this page and then I'll go to SSH Client. All right, I want to use an SSH Client to access, all right, my key pair. Now, let me launch, all right, my PowerShell. I'm going to use PowerShell on my Windows, and then I'm going to run that as an administrator, right? So run as an administrator. So yes, I'll do that. Now, from this administrator's page, we want to do a few things. Now, we want to connect, all right, with our EC2 instance. We don't want to go through this option, okay? We want to connect with our instance right here. Now, don't forget that we downloaded a key pair earlier, which was downloaded into the downloads folder, right? Now I need to navigate to the downloads folder. And if you look at this place also, it gives us, right, an instruction. So if I click here, let's see. Oops, sorry. Right, now it gives us some instructions on how to connect using an SSH client from here. The first one is open an SSH client, locate your private key file, run this command, right, on the key, and then connect using this, right, details right here. And then an example of how we can connect is this, SSH-hi, all right, specify the key pair, and then the DNS name of your instance, okay? Now let's do a walkthrough of all of that. Now I'm going to do, the first thing is to locate, right, my private key pair. So CD, all right, / to go to the root directory. And then I will do CD, all right, the users, and then name of my user is this. And then I want my key pair was downloaded inside of the downloads folder. So I'll navigate into that downloads folder, right? And then let me clear my screen here. If I do ls is to list the content of the downloads folder, right? That is what ls does. Now, my key pair, I need to look for it here. Now, my key pair is right here, freeclass.pem. All right, that's the name of my key pair. Okay, that's what I'm looking for. So what does the thing say? I've located it now, and then it's asking me to run this command, all right, on the key pair to ensure that it's not publicly accessible. That's what it's saying. All right, so I would clear my screen again, and then I will run that particular command. So let's copy it, all right, and then let's paste it right here, and then let's press enter. All right, so it's telling us the chmod command is not recognizable because the chmod command is actually a Linux command, all right, and it's not recognizable on a Windows machine. So there's no way we can run that. All right, now, so the good thing is that we have been able to locate, all right, our key pair, and the key pair is right here in this place. So let's try to connect to our EC2 instance, and let's see how that is done. So if you're going to follow this example that we have here, we can do SSH-I to make it interactive, and then our key pair, so which is freeclass.pem, that's the name. And then we also have to now copy the, all right, this name here, which is the address of our instance, and then we press enter to authenticate to our server. So it's asking us, are you sure you want to connect to this particular server? And we say, yes, I want to connect. So we say yes. All right, but then there's an error. Now the error here is permission denied, all right, because we were not able to run this particular command. Normally it is expected us to, all right, ensure that this key pair is not publicly accessible. Okay, and so since we are not able to achieve that, it won't allow us to, all right, to connect to it. So what can we do in that regard? Okay, so what can we do? Now let me see if I have Git Bash here. I don't have Git Bash. All right, so what can I do in this regard? I really want to show us this. So let's see what we can do. Now I can install a software called Git Bash, all right, which I can do from Chocolati. All right, Chocolati community. Okay, I can install it from there. Now the Git Bash, what the Git Bash does for me is that it gives me, all right, like a Linux environment where I can run some of this Linux command in order to make sure that that key pair is not, all right, publicly accessible. Okay, so let's see how we can do that. Now, while we wait for the Chocolati to come up, there's another application we can use, which is called Tamius. All right, so let me open it up. Okay, so here, all right, I can look for Git from here. So it gives me this. So right here, I can install, all right, this particular one. So I'll click on copy. I can go back to my PowerShell and then click on this one right here. And then I can put in my -y to accept all the default. So basically I want to install Git. And then what I really need is a Linux environment, right, to be able to run this Linux command. So press enter. So allow this to install while we look at the Tamius guy. So it's running already, right? So let's go back to Tamius, right? Now, time use, it's like a normal terminal emulation, all right, software for SSH and all of that. Okay, it's more like your PuTTY, MobeXTAM, and some of these other applications. Okay, so that's what your time use it's about. Right, so let me just skip all of this. I'm just going to skip this. I'm going to skip all of this. Okay, it's asking us to log in. Do I remember my login videos? I think I logged in once here. Did I forget? Okay. Just a minute. Let me see if I can just get the login credentials. All right. Come in. Let me see. Okay. All right. So I'm trying to log in now. I'm just trying to be careful with that. Okay. All right. I'm trying to log in. Just um, okay. Just trying to do my authentication. Okay. If the timers does not work, we have to just download PuTTY or any other one. Okay, I think. Oh, okay. Mhm. All right, the Git is still installing, so let's just wait for that to wrap up. All right. Okay, so while we're waiting for Git, let's look at Tamius. Right, I was able to log in into it. Now, this is how the Tamius looks like. All right, you can use it to do SSH into any of your instance in the cloud environment, right? And it's free, it's open source. You can go online and download it, okay? So now, if I want to, let me reshare my screen totally again, right? So I just have to, for security reasons, right? So now, if you want to connect to your, all right, your EC2 instance, right, using an SSH client. Now, one way is to do the CLI, which is the command prompt that we are trying to do. But once the Git has been installed, we're going to see how to do that. Okay. Another way is to use an SSH client. So we have PuTTY, we have Tamuse, we have there's the secure CRT, there's MobeXTAM, and all these other applications. Okay, well, let's just go with Tamuse, right? So now, how do we set it up with Tamuse, right? Pretty easy. Okay, so we can go to new host, and then you can call this the OS that we're using is actually AWS, AMI, right? So we're gonna say Amazon Linux 2023. Okay, that's the name. Okay, so what's the address? The address is this. All right, the address is this, or you can also copy the public IP address, whichever one you copy is fine. So you can copy the public IP. So you can put it there. All right, SSH. Yep, that's port 22. What is the username? The username is right here, EC2 user. All right, or we can go to SSH Client and just copy the username here. So EC2 user is the username. Okay. Now, password. We're not using any password because we didn't create a password. What we did was to create a keypad, and that keypad, it was downloaded on our system. So we need to set a key. So we click on set a key. I already have one here, but we're going to use a new one. And then we're going to import it because we downloaded it. So we click on import, and then we go to downloads, and then this is the key that we downloaded. So we double click on it, and then to put it right here, by itself. So once that is done, you can click on save. To save that particular key. You can see now that the key, is showing up in that space. Okay, do we have it here? All right, so let's click on it again. So this is the key. All right, so the key is there. All right, now that's all that we need to do. Now, once that is done, you can use this to save, and everything has been saved. You can click here to connect to your Linux. So here you click on add and continue. All right, and then let's wait for it. All right, so you can see that we are already inside of our environment. Okay, so if you look at it here, we're in our environment. So if I want to check if that is true, that's pretty easy. So you can see that we're in an environment. So we are inside of the EC2, that we have connected here. So if you want to be sure, you can go to Instance Connect, and you can click on Connect to connect it. All right, if you're in doubt, you can also use that option to verify if truly, you are in that same environment. Okay, so let's allow this to also come up. Now, the difference between this one Instance Connect and that other one is that your Instance Connect really does not necessarily need a keypad. While if you're connecting using an SSH client, you need a keypad for that connection. If you look at it here, EC2 IP address 10.243 is also the same thing that we have here, 10.24.3. And then if you do cat, just running the Linux command now, etc/os release. Okay, so that should show you the version of the OS that you're running. So it tells you you're running Amazon Linux 2023, and all those kind of details, it's available. So here also, if I do cat /etc/os, release. So I get the same option. Amazon Linux 3, 2023, ID Light Fedora, version is 2023, Amazon Linux, blah, blah, blah. Everything is pretty much the same, Okay. So here now, I can do anything that I want from here. I don't have to go to my browser. Every command I want to run, if I want to do any setup, I can do everything from this particular, interface. Okay, so that is one way to connect to your EC2 instance using your SSH key. Now, if you pay attention, you will discover that with this option, we didn't have to, all right, we didn't have to run this command, chmod 400, because basically the content of this key was somehow copied, okay, was copied, all right, into this way because we imported it into this and then it copied the content and then it pasted it. So we didn't have to, okay, run the chmod, all right, command on top of that. Okay, so that's the difference between the instance connect and then using the SSH terminal. Now, in a real world environment, you're not going to be using the EC2 instance connect because most likely you're not going to be running your workloads using Amazon Linux AMIs, right? You're going to be using maybe Ubuntu, Debian, and all those kind of stuff. But if you're running a Debian OS, all right, within the cloud environment, your instance connect does not really seem to work well, all right, with that particular operating system. Okay, so at the end of the day, you must still know how to use applications like Terminus in order to connect with your application. Okay, now this one is still installing. So if it finishes, all right, we use it. We also see how we can use the Git to connect with it. And if it does not, all right, on Wednesday, you look at that option, all right, as well. Okay. So this is how you can use this. Okay. So if I want to check out of here, I can easily come here to, all right, click here to share section. Let's see. You can right click on this and then you can close this. Okay, so if you right click on it, all right, so you can just close it and then you shut it down. You simply just close the terminal, all right, that way. Okay, so that's how you can use this to connect to your EC2 instance. I'm going to show us this. Let's just allow this to finish. Now, quickly, okay, our time is fast spent already. All right, so that's a little bit about how to connect to the EC2 instance. Now, that is not all that there is, all right, to EC2. Okay, now, for example, let's look at, now under this place, there is, all right, what you call a reserved instance. Now, if I click on a reserved instance, what does it mean? Now, let's talk about that as we wrap up. Now, I've shown us the different instance types that are available, all right, that we can use, that we can choose from. But also, you have what you call a reserved instance. Now, this instance that we launched here, right, the free class VM that we launched, is categorized as a dedicated or an on-demand instance type. How do I know? If you click on launch instance, all right, if you click on launch instance, now if you scroll down to instance type, you will see here that it tells you that the on-demand, everything here is on-demand. All right, so the on-demand price for Windows is this amount, the on-demand price for Red Hat is this amount, for the normal Linux, which is Ubuntu, Amazon Linux 2, Debian is the price. Now, on-demand, what does on-demand, what does it mean, right? If somebody says, oh, this thing is an on-demand instance, what does it mean? Now, on-demand in the layman language is basically means pay as you use. All right? That's what on-demand means. It means what? Pay as you use. That's what it means. Pay as you use. All right? That's what on-demand, which means you are paying as you are consuming those resources on a hourly basis. All right? That is on demand. Now, within the cloud environment also, Amazon has other offerings. All right, we've seen the instance type, right? There are other options as well. Now, you can either go for the on-demand, which is pay as you use, which is every hour, all right, you pay. Now, if you look at my environment here, I have some instance, all right, that I have some instance here, but they are stopped. I'm not using them at the moment. Now, the mere fact that these instances are stopped means that I'm not going to get charged because I'm not using it. Now, these instances are on-demand instances, which means I pay per use. But right now, I'm not using it, so I'm not paying. Okay, I'm not paying for use. I'm not paying because I'm not using it, right? Now, there are other options too. There are other deployment options. And one of them is the reserved instances. Now, reserved instance just basically means you as a person, as an individual or an organization, you know that, okay, you have a workload that you want to run, and then you are going to run that workload for 1 year non-stop, or between 1 and 3 years non-stop. So which means that the moment you deploy the server is going to be active for at least a minimum of 1 year without any interruption. Now, if you have that kind of use case, you don't want to go with on demand, because for on demand, the pricing, it's a bit expensive, right? Because you are paying per use. But then if you want to lower the price of what you have to pay, okay, you can go with a reserved instance. But then you must ensure that the instance that you are reserving is something that you will use consistently for at least 1 year. All right. So that's where the reserved instance comes in. So for example, if I want to purchase a reserved instance, maybe I just finished the meeting and then they told us, oh, we need a server up and running. We need to deploy it right now. And then we have a workload we want to run for 1 year, not interrupted. I wouldn't go for an on-demand instance. I would rather go for a reserved instance, because I know that's going to be a huge cost savings for my organization. Now look at what they have here. He said, we recommend saving plans over reserved instance. Saving plans are the easiest and most trusted way to save money on AWS compute, and they offer 72% off. Now, saving plans is here. All right, so you can go with that as well. Okay, you can go with saving plans also. All right, if you want to also, so you can click on purchase saving plans. All right, from here. But let's go back while this is loading. Let's go back to reserved instance, and let's see that. And let's see the difference between a reserved instance and an on-demand instance. In the meantime, let's check our installation. Okay, it's still going on, right? Now, if I click on purchase reserved instance, it's going to give me this particular dashboard. And that particular dashboard is just more like, is more like, you want to make an order on Amazon. So you put everything into a cart and then you check out. All right. And then once you check out, you put in your details, card details, and then you pay. And everything is done. All right. Now, for example, let's say, okay, I want to reserve a Linux, all right, instance. The default, I don't mind. It can be the default offering class. I can choose any. Now, there's two. There's the convertible. There's the standard. Standard is anything that you start with is what you're going to use all through. Convertible is if I start with T2 and then I feel that, oh, my T2 is no longer be able to serve, all right, the purpose for which it was created. I want to upgrade from T2 to T3. Then you want to go with convertible. Okay, well, let's leave it at any so that we can look at the pricing. All right, so let's say, okay, I want to start with T3 micro because that gives me 2 virtual CPUs and 4 gig of RAM. So I'll go with T3 micro, right? Now, term, I can say between a month to 12 months, but the minimum is actually 12 months because it's a reserved instance. And I can also say, okay, you know what, 12 months to 36 months, which is actually 3 years. So let's leave it at any as well. Payment option, do you want to pay upfront? Do you want to pay partially? Or do you want to just, all right, pay as you use? But of course, you have reserved that capacity. So let's leave it also at any, and let's see something. So I will click on search. Now it gives me different options. Now the seller is AWS. The term is 12 months. The effective rate is 0.007. Now let's compare. So let's go back to instance from here. And now don't forget the instance type that we chose is what? Is a T3 micro, right? So let's go to instance. Let's launch instance. All right, so in this place, instance type, load up. All right. Now, in this place, let me go to T3. Now, what we used was T3 medium, right? Medium, okay? And then, oh, sorry, T3 micro, okay? So let's go back, let's change this, T3 micro. All right. Now, let's look at this together. Here, we chose Linux Unix, so which means Ubuntu, Debian, and Amazon Linux, right? So let's look at the price. Now, the on-demand price for the Linux, this is what we're looking at, is what? 0.0118 cents per hour. That is on demand. Let's look at the result one. Look at it. 0. What? 007. Look at it again. The price is what? 0. Let me zoom it in case. Look at it here. This is what? 0.0118. That's kind of high, right? Let's look at the result. Look at the result option. 0.007. That's cheap. Now look at it again. If you are reserving this instance for 3 years, look at the price. 0.004. That's cheap. And if you want to pay everything all upfront, which means you want to pay for the whole 36 months, right? You want to pay for the whole 36 months, you're only going to pay $117, right? Now, if you calculate this 0.118 per hour, let's do the maths. Okay, let's do the maths together. So you have 0.0118 times 24 hours. All right, so in 24 hours, that is going to give you 0.283. So for 1 day, this is what you're going to expend. This is going to be your cost. Now, this one times 30 days, you're going to spend $8.96 for 30 days. Now, let's times this by 12, which is 1 year. That is going to cost us $101.952. Now, we look at the price compared to 12 months, just 61, right? Now, 61 minus this, that's some cost savings, right? So you can see that the result instance is cheaper than the on-demand. Now, times 12 again, so let's do this times, let's say times 3, all right? That will give us, okay, I was supposed to do times 2. All right, so that's going to give us at least, but whatever it is going to be much higher than this. So for 36 months, which is for 3 years, if we pay $117, we can have this instance for 3 years just at this price. That makes a lot of sense, right? So that is the difference between an on-demand and, right, the reserved instance. Now, it talks about a savings plan as well. If you look at a saving plan also, you can also purchase a saving plan, right? If you click on purchase a saving plan, it will take you to this place. You select the term, let's say 3 years is what you want to use. All right, you can do complete saving plan, apply to instance, blah, blah, blah. So let's say 3 years, all right, hourly commitment. Your hourly commitments are saving plans, applicable rate. So you can see the plans from here, and then it will tell you. So if you click on this place, it will give us some information. All right, the hourly rate and all of that. So let's see the hourly rate from here. If we're going to give us anything. All right, this is loading up. All right. So, but basically what we're just trying to say is this, that if you have a workload that is going to run for at least 1 year without any interruption, you don't have to go with the on-demand, just go here and reserve, all right, an instance. Now, even if you choose another one, so let's say we're doing T3. All right, let's say we want to do T3 medium, okay? Let's search and let's see what the cost is. Now, for T3 medium, the cost, all right, for 36 months, which is the standard one, is $466, all right, for 3 years. Now, for just 1 year here, which is the standard also, is going to be $243 for 1 year. But then if you go back to launch instance and you change this to, all right, T3 medium, let's see. Again, look at the hourly rate. The hourly rate here is what? Is 0.0472. So if we take our calculator again and do 0.0472, all right, times 24 hours, that's going to be $1, 132.8 for 1 day. For 30 days, all right, that's going to cost us $33 times 12. That's going to cost us $407, right? If we have to go with on demand. And look at what we have for reserved just for 1 year. For 1 year, it's just 243 compared to 407. Look at the gap. Okay. So for organizations that know that they are deploying an instance that is going to run for at least 1 year without interruption, they go with a reserved instance, because that way they're going to save themselves a lot of money. You can look at the difference that we have here. 407, all right, compared to 243. That's a huge gap. That's almost close to 100% difference, all right, in price. So that is the difference between a reserved instance and an on-demand instance. So pricing makes a lot of sense. So the difference is this: if you have any workload that is going to run at least for 1 year uninterrupted, just go for reserved instead of using an on-demand instance, right? But if you know you have a workload that you can interrupt anytime within 6 months or within 3 months or so, then you can just go with on demand. Or maybe you have a workload that you just want to test out a few things within a week. You really don't need any kind of commitment. Then you can go with on demand, all right, kind or type of instance. Okay, so that's where we're going to stop, all right, for today. Let's quickly look at this. If it's done, right? We had a little issue. Okay, it's all right. We're going to install this later. I'll try and install this before the next class so that we can see how to work with this. Also, how you can authenticate if you don't have the time use, how you can authenticate using the CLI from your Windows system. All right, I'm going to work on that in the next class. Maybe that the network is a bit slow. That's why it's not able to download as it should. Okay. All right, so we're going to stop here. So in the next class on Wednesday, we're going to look at the CLI stuff, and then we're going to look at the AMIs. We're going to look at volume snapshots. All right, we're going to explain all of that, what it is, and how you can use them. All right, also. All right, so that is what we have for today. Okay, so I'm going to see you on Wednesday, but in the meantime, if you have any questions,